So welcome to today's talk on NixOS. I hope you find this interesting. It's going to be a bit technical. So what is NixOS? NixOS is a Linux distribution based on the Nix system. What makes it different than your standard distribution is NixOS is what we call a declarative system, where most Linux distributions are imperative. These are terms borrowed from the world of programming. And in traditional programming, you have most languages being imperative. Imperative is you sort of give a sequence of steps, where declarative is you say what you want. And declarative is sort of the more common way of sort of humans doing things, but in computers we've got so used to being imperative that we tend to think that way. So basically, in an imperative system, you have some sort of initial state, and you mutate that state. So some sort of initial set, like you've installed, say, Ubuntu, that gives you initial installation of Ubuntu. You go in, you edit configuration files, so you're changing the Ubuntu installation. You're adding packages, you're removing packages. And eventually, hopefully, you get a Ubuntu system configured the way you want it to be configured. Whereas a declarative system, rather you specify the final state you want for the desired system. So you'd say, okay, I want this set of package, I want this set of configuration options, and then the system goes and builds that according to your specification and gives you that system. You can kind of think of it, if you're thinking of like a cake, one way is I give you a recipe for making the cake and you follow the steps. The other way is I give you a specification of what type of cake I want. So as I said, imperative is what we're used to, but there's actually a lot of things that aren't so great about imperative. First of all, we're not working with what we really want. If you're thinking of the recipe analogy as well, I'm giving you the steps to make a chocolate cake. And if you're familiar with baking and stuff, you can probably look at those steps and like, oh, he's adding cocoa in here and stuff. This is probably a chocolate cake, a recipe for a chocolate cake. But as a human, it would be much more useful to have actually said, I want a chocolate cake, instead of always speaking in terms of the recipe. So we're always having to think in terms of the recipe on an imperative system, the set of states, the packages, the config files. And then not only that, it's not supposed to, but frequently the state changes interact in unhappy ways. So if we're saying we install this package and then we remove it, ideally we get back the system that we had before we installed it. And Linux, that's pretty good. But as you know, if you've ran Windows, that's most certainly not a safe bet. In fact, at some point, you just have to reinstall your entire operating system to reset the state back to zero. Because once you install something and you remove it, you never go back to what you had before you installed it. And your system slowly gets cruftier and config files get left around, and it's just not, does not work terribly great. So here's some of the things, right? Sometimes it matters what packages is installed first. Ideally, you should be able to install your packages in any order. Installing and removing a package is generally not the same thing as never installing it. Installing an older version and upgrading probably does not give you the same result as just installing the newer version. If you've had to upgrade these systems, you know, it's not uncommon for people to just say the best way to upgrade is just to format your hard drive and install new pristine, and then you don't have a bunch of cruft left over from the old system. And then when you're in a situation where you're maintaining thousands of computers, as we do, then this is much worse, because each of these computers have their individual states. And if they haven't been through the exact same sequence of steps, say one was down to some sort of hardware failure when you did some updates on the other ones, then they get out of sync. And you run a command and it fails on this one because it's subtly different than those other ones. So various attempts to cope with this is sometimes we try and maintain just a few master images that are duplicated everywhere. This is what we do at SharkNet. So we have sort of one master image shared over a file system, an NFS file system, for what a cluster image should be. And then, the 1,000 computers that are compute nodes all boot that same image. So we got one system that we mutate to have the state. So that instead of individually thousands of computers. In the past, we've had ones where, thinking of the original HP system, I believe, where we had them individually, or another common one is when they boot, they download the image and reflash the hard drive. You find that sometimes in computing labs, it takes forever to turn a computer on after it's been turned off. And then finally, more recently, we're seeing more what I'd call bolt-on declarative systems. So Ansible, Puppets and stuff. And these are systems where you have recipes and stuff, and you sort of give a description of what you want, and then it goes out and it runs on the machine and tries to see, what needs to be done to bring it to that state. So now you're acting much more like a declarative system. You say, okay, here's the list of secure shell keys I want. Here's the list of software I want in the system. And then these systems go out and connect to the machines. Under the hood, though, Ansible and Puppet are still mutating the state of the system. We're hoping that they're doing it successfully. And ideally, if all these files are well written, it should work. But it is a bolt-on system. So Nix, underlying NixOS is the Nix functional package manager. And sort of the whole functional, as I said, we have the typical programming languages, your declarative ones versus your, which is example Nix and Haskell and programming languages like that, versus your classical programming languages, which would be like C and Python and stuff, which are very sort of recipe oriented, the imperative ones. So NixOS is actually picking up the whole declarative thing from the fact that underneath it is the Nix package manager. And it's a functional package manager. And it has it was a lot of the semantics brought across from functional programming languages. I hate to say it's a package manager, though, because when I say it's a package manager, it gives people the sense that they have a basic understanding of it. They're like, oh yeah, I've used Yum, I've used apt, I know what a package manager is, but that throw away all that knowledge. Do not think that. If you think that with Nix, you're going to have a lot of frustration. And it's actually, it makes it harder to understand, in my opinion, because you have to first unlearn what you think you know before you can learn the new system. So the Nix functional package manager is actually a software for building and composing systems. So basically, it's putting together Lego bricks and building bigger structures, and then putting those structures together and building it into even bigger structures. So I like to think of it as a building and composition system. What's unique about this, again, from the functional programming languages, with the compositions are what we call pure. So they're determined solely by their input declaration. So this gets away with there is no state. And Nix goes to a lot of extremes to ensure there's no states. When it builds a composition, it builds it in a lockdown C group, actually, jail on Linux. So it has no access to the network. It has no access to any of anything but what was declared as an input to that system. So it could be source code, it could be other libraries and stuff, but only those are made available for that building process. And then when that building process is done, that's it. You have it, it's written out, it's all marked read only, and it never changes. So it's immutable. And that also, then that allows you to share these compositions. So, if you say, I want this built, and I say, I want the same thing built, then we can just share the results of building one, because, it was built in a way that you should get the same results all the time. You had the inputs were specifically declared, and it is not allowed to change after that. And then finally, sort of one of the real keys of building stuff in computer things is you have to be able to build bigger building blocks. And Nix definitely does that. So its compositions are composable. You can use them to build even bigger compositions, and then you use those to build even bigger compositions. And I mean, hopefully this here gives you, this is not something you would talk at all about with a regular package manager. So Nix is really not a regular package manager, even though it's called a package manager. So what is NixOS? NixOS is what logically falls out of this when you just build your entire system in the Nix package manager. So it starts from basic bootstrapping libraries and tools. Most of this has already been built upstream, and because it's it's immutable, and it was built in a clean room environment, your system just downloads these actually instead of building them yourself. Although you can force it to rebuild everything from scratch if you want. So yeah, so starting from basic bootstrapping libraries and tools, it builds your main tools, and it just keeps building, and then uses them to build additional stuff, and it just keeps rolling these components together until at the end you actually have an entire file system. You have your etc tree all defined, all your configuration files, and all of that is built from your single declaration of what you want in your system. So the final output, the final ultimate thing that is composed with NixOS is a complete operating system. And you'll find this with NixOS. So, I mean, and then people have actually built on that instead. They're like, okay, well, now we have a way to build individual computers. Let's build groups of computers. And that gets into NixOps, where you declaratively define entire systems, and then you can just push them up to like the Amazon Compute Cloud and pave 3 or 4 machines that you got your mail server and your database and your web front end and stuff like that. But we're stopping at NixOS here today. But basically, part of the message or part of the beauty behind NixOS is that the rabbit hole is deep. You go down and it's just the same thing again and again and again, which shows that it's actually a beautiful abstraction. And it's consistent all the way down. It's turtles all the way down, to borrow an expression there. And you can actually have any number of system declarations coexisting on the same machine. All the basic, this sounds like, oh my gosh, I'm going to build the operating system every time. But because it's built out of individual bricks, and those bricks are shared, it never rebuilds something that it already has. So when you make a change, it just makes the minimal rebuild necessary to make your change. Like you make a change in one of your configuration declarations, it basically rebuilds that configuration file and then creates a new etc symlink tree that puts it all together. So it's actually very quick, and it's also very fast to have multiple versions of almost the same stuff all coexisting, because you got just the differences between them and all the commonalities shared. If you use NixOS, you kind of cringe with Docker, where people are rolling out entire distributions with lots of duplication between them. It's your I guess hard disks are cheap now, but maybe I'm old enough now. I remember I still think of storage as kind of valuable. And then just as a bit of joke, yeah, so great that GNU forked their own Guile-based, of course, some Lisp there, free software only version. So there's also Guix, which is the GNU system, a little bit remnant of Herd being replacing Linux. So if GNU forks you, I think you're maybe doing something interesting. So now just a word of confusion: the term Nix is highly overloaded and context dependent. So there's Nix, the pure lazy functional declarative language. So that's how we declare the stuff we want. We'll look at that. There's Nix, the software composition and building system based on Nix, the language. And there's NixOS, which some people just refer to as Nix as well, which is the operating system built on the Nix composition and building system. So there's a sort of a stack of things, and then there's additional stuff on this when you start looking at cloud deployment and stuff as well. So I guess this is sort of your description here. So you got Nix describes your compositions, then Nix, the building system, composition and building system builds that, and then when you take that to the logical conclusion of building an entire operating system, you get NixOS, the operating system. So one of the things that I just recently updated my computer, the version of NixOS I was running. So when I first started using Nix, I was using it just the Nix, the package manager, if you will, the composition system. You can install that. It's extremely easy, a simple shell command. You can bring that into an existing Linux system. I've ran Debian for years. It was sort of the first distribution I had. And then at some point, every time I went to upgrade Debian, it was basically I set aside a day at least, because things would break. It was that whole sort of state composition thing, and you just hoped that nothing serious would go wrong, because you really could not, once you'd started the upgrade, you were going down that upgrade path and there was no coming back, except for restoring from disk. Once it's halfway through removing old packages and installing new packages, that's where you are. So I installed Nix at one point because I wanted access to some packages, but I did not want to upgrade my system to the next version of Debian yet, because I was busy. And eventually it was there and I ran it. And at some point I realized I'm actually running most of my software out of Nix, and my Debian system's old and I haven't updated it in forever. Maybe I should just try the Nix operating system as well. So at that point, I switched to NixOS, and it's definitely a different way of doing things, and it's generally a little more painful. You have to look up, if you're familiar with the traditional config files and you've got all that knowledge in your head, you're now declaring them, and I mean, although there's a nice consistency to the declarations, they're not something that you know offhand. So there is some growing pains there, or from the personal level, but it's so nice to upgrade, and once you've got a declaration and you're rolling with it, taking it and doing another machine. I have several machines in my house and at work and stuff, and I cut and paste little bits of the declaration between them, and it's just really nice once you get going. So this last upgrade I did, I happened to notice that actually NixOS is now, they were accumulating packages, and it creates a lot of excitement, especially amongst the people interested in functional programming, because, hey, here's a functional operating system, a declarative system. So there's been a lot of people attracted to it, have been doing a lot of work. And now it turns out that NixOS is actually, if you look at the repology.org, repository statistics, which basically just tracks a bunch of packages across many distributions and checks to see how each distribution is doing relative to the others. NixOS has become huge, basically. According to Repology, it's got 53,079 packages, which makes it the second largest after, I think, Arch Linux is the largest at about 57,000. And I mean, hugely more than Ubuntu's 31,000 or Fedora's 22,000. I didn't put Debian on here, but yeah, also way bigger than Debian. And then most amazingly, it's got the most up-to-date package set. So of those packages, of the 53,000, 80% of them are at the newest version. So of all of the distributions that have that package, Nix will be right there at the top. If you compare that to Ubuntu sitting at 64% or Fedora's 42%, it's really, I don't know, I was kind of blown away, which is what inspired me to give this talk. I thought, well, man, Nix is really becoming a serious distribution. And so, yeah, and due to its sort of esoteric nature, it tends to attract a lot of very bright people who are interested in the esoteric languages and stuff. So it has some really nice, apparently not people, someone who can spell though. I'll just click on this one here. It has some very nice support for a lot of different languages. So let me just jump back up to the top here. I think they've used to have these. So let's just search for something. 1510. So my link was not as good as I had hoped. But basically, a lot of these languages have okay, yes, here we are. So it has a language framework for supporting a lot of different languages. And certainly, as someone who plays around with Haskell, it is one of the premier systems for doing Haskell development. So Commons Haskell, it's got a whole system for managing the Haskell packages. Same with Python. And lots of, kind of these vague languages like Coq and Agda and OCaml are. So Nix has been on the clusters for a while. It's been on the SharkNet clusters. I don't remember when we first put it on. For a long time, starting on our legacy system. And the purpose was just because it has this big package set, and you can use the Nix package building and composition system so nicely inside another operating system. We figured we might as well just make it easy. It solves a lot of the common requirements. I mean, the CVMFS stack has picked up a lot of this stuff now, but generally the clusters, we had a CentOS distribution where we don't want to run them on the the bleeding edge, and we're quite often frequently tied to, or at least we have been in the past, tied to running older enterprise versions because we have special hardware like special network drivers and stuff, and we have to use a vendor's driver file and stuff like that, and it only runs under, we can only get the drivers patched for Red Hat Enterprise 6 or whatever they're releasing. So quite often, compared to what you would have on your desktop, our clusters are running a relatively old stack. So Nix was an easy way with its package set to bring some of the more common tools that people might want to use. So new versions of Git and new versions of FFmpeg and just these sort of basic tools you would use. And because it was a complete system, it had all the dependencies too. I remember the first time I way back when I joined SharkNet, I went to build the newer version of ParaView, and how deep did the rabbit hole go? Well, I had to rebuild bin utils at the end because newer C++, newer CMake, using features that weren't available in that particular release of the linker and stuff. So at some point, it's really hard to build software once your system lags far enough behind. So it brings up a nice thing for the cluster. So it gives each user their own environment. You have complete control of what's in your environment. You can install, you can remove packages, just as if you were the system administrator. You can go in and you can override any part of any component. So you can pass different config files. You can pass different options to the CMake system. You can specify different dependencies. You can change, replace some sort of library with a different version of it. And then all the components are automatically shared to the fullest extent possible. So if I'm using something and you're using something and we're asking it to build the exact same thing, it just gives us both one copy, right? So it's friendly on your disk space. And you can have any number of versions and any number of builds of each package. So I can have Git built in 10 different ways, 1.3.2 or whatever. That's no problem. And then to manage all this, again, it borrows more from our functional programming space. It's got a garbage collector, so it goes around, it sees what you still have access to, and it leaves stuff there until people no longer have access to it, at which case it goes around and sweeps it out under the rug. So it automatically reclaims the space. And then finally, one of the really nice features is all operations are fully atomic. So they succeed or they don't change anything. So you're not breaking your system. Which is sort of the unhappy state I started with in the Debian world. So on the cluster sort of side of things, whoops, I seem to have closed my web browser, unfortunately. I'm going to just start it up out of here. I have to specify the no GPU flag new version of Chromium, otherwise it's horribly slow. Yeah, so our docs compute-can.ca. So when we got the Graham cluster, we put Nix on the Graham cluster as well. I'd hoped it kind of would spread to the other clusters as well, the other Compute Canada clusters. It hasn't yet, but that would be nice. So if that is something that you would like, you can help push us that way. So there's just a generic sort of description here, how you can use the Nix commands, existing compositions. So how to just run stuff like, here's how to find Git and how to run if you want to just run it once. If you want to create a kind of like a Python virtual environment with it in it, if you want to permanently install it in your own personal environment. And then how to build more sort of advanced stuff, how to build a virtual environment that has a bunch of different packages in it, how to select your Python packages, how to build your R packages, how to set up your Haskell packages, and how to do your Emacs. This is just the basic ones that so far have come up. Of course, you can refer to the actual sort of Nix page, a Nix upstream documentation. So this documentation is available. So now, without much further ado here, I'm going to actually run out of time before I can show you anything. We'll get started. So Nix has a lot of very good documentation. So there's the software declaration system, there's the language, there's the packing infrastructure, the operating system. And then it's got these nice interactive websites as well here and I shut my browser down, for looking at packages and looking up system operations. So let me bring my browser back up. So packages here. So you want, okay, what do we got? Git looks like 2.2.8. And you can check which in the sort of the last couple releases of NixOS, unstable being sort of the bleeding edge. You can click your way through here to the underlying Nix expression. Oh. That did not work very good. So at least in the past, you could click your way to here, and that would take you to the actual sort of declaration of the Git build. Let me just try another one here. That might I saw that's a link to a specific version of the in the GitHub. So yeah, so they'll have to fix that. Maybe I'll file a bug report. Anyways, and then there's the system options as well for looking up basic system operations. So say, you're saying, oh, I want to use the exam mailer, that. If you type exam in here, it sort of gives you some of the sort of settings that you can set in this declarative stuff. So we'll be looking at that shortly. Okay, so I'm going to build a system here from scratch. Since it's coming up from scratch, I'm going to have to partition it. So I don't mean to scare anybody, but that's one of these things you do. So you take up your hard disk, you chop it up into 3 basic areas. I'm going to start with a 16 gigabyte, I'm going to do this in a KVM image. So I'm going to start with a 16 gigabyte disk. I'm going to chop it into an initial 1 gigabit EFI system partition. So that's extensible firmware. These are approximate numbers due to the ending and starting has some partition table data and some boot area and stuff around it. So 1 gigabyte space for the extensible firmware image. Basically 14 gigs, so from 1 gig to 15 gigs for Linux, and then just throw a 1 gigabit swap partition on the end. Again, it doesn't quite go to the end of the disk because the partition table headers are duplicated at the end, so slightly less than that. And so then, yeah, basically around the start here, there's going to be a BIOS boot area for historical reasons. Your EFI partition does not actually start until 1 megabyte into the disk. So there'll be a small area in there. Back in the old days, when computers used to have the DOS and stuff, basically the program loaders were stored at the front. So if you're booting off the old BIOS system, there's a bit of your disk at the start where you put your copy of Grub or Lilo or whatever's handling your boot system, bootloader if you're using Windows. So this is an area reserved for that. The new systems use the EFI system, which they put the bootloader stuff in a FAT partition. And so that would be that. So then this system will boot either EFI or BIOS. So okay, so let's get underway. I'm going to do this on a machine at work here, just because if I do it on my machine at home, it's going to be downloading software that'll slow down, and I don't want, you know, extra strain on my internet connection when it's already streaming the video from this thing. I'm going to do it under KVM, so I'm going to open up the remote display in a VNC session. So VNC just gives you a shared desktop basically. So I'm going to forward port 5900, which is the first VNC connection port, to the remote machine, connecting to 5900. So I'm basically, this is just forwarding over my VNC system. So I'm going to take port 5900 on this system and I forward it to the local machine to its port 5900. So basically put a hole through our firewall. And the machine, this is not a machine you guys would use. It just happens to be one that I have access to. I was going to use my personal desktop at work, but it happened to have died overnight. So I'm going to use this one instead. So we log in. There we go. And there's just some old file I had in there. So I want to download the basic Hydra image here. Let's put this over here. Not the basic Hydra image, pardon me, a basic NixOS. So the way you install NixOS is you boot NixOS. So you get a USB stick or something like that, and you boot that. So if we go to the NixOS page here, we can go to the download. We want to download an ISO image here. A minimal ISO image. And this here, if you can read right at the bottom of my screen here, this is going to take me to the 2009 release of NixOS. So the 2009 release is the one that was released in 2020-09. So that's September of 2020. Nix is released twice a year in 03 and 09. So your releases, last release was 2003, and then the earlier release beyond that was 1909. So I'm actually going to install a 1909 Nix image for us, just so we can see the upgrade process. So I'm going to take one that's a year old. So I'm just pasting. Normally you would just click this here and download the ISO image, copy that to your USB thumb drive or burn it to a CD and boot your computer. What I'm going to actually do though here is I'm going to have a look here on our channels here. So I'm going to go with a 1909 release. There we go. And I'm going to do a minimal image here. And I want the x86-64 Linux. So I'll just take this link here, copy link. And I'm going to download it on this machine here. So wget, I'll just paste that in there. So this just makes this download this minimal image that I would then just transfer that straight onto my USB thumb drive, reboot my computer. But if I did that, of course, then we would lose my session with you guys and you wouldn't actually get to see what I'm going to do. So we're going to do this instead through QEMU. So I'm going to run a virtual machine on this Hydra computer. So first I'm going to create a disk here for QEMU. So, and this is just a QCOW2 format. This is just QEM specific stuff. But how big? We're going to make it 16 gigabytes. And I'm going to just call it NixOS Q. So this here just basically made a fake disk image for my machine. So my machine's going to think it has a 16 gigabyte hard disk. All right, and then what we want to do is we want to boot the machine. So we're going to run the QEMU KVM. So that's the hardware accelerated virtual machine. Just turn off the default KVM settings. This is going to be a lot of config options here. We're going to have 8 gigabytes booted up with, say, 8 gigabytes of memory. We'll throw it in 2 processors. We're going to take its display and we're going to send it to localhost:0. So that matches up where I ported port 5900. That's the VNC standard. they take your, what would be checkable your X display number and add 5900 to it. So this is the other end of the VNC connection. We're going to boot the first time off D, which is the CD-ROM. We're going to start it and stop in suspended mode, and I'm going to enable the monitor. So that allows me to type commands right into the QEM image. So I'm going to put that on standard output. So that's the basic machine parameters. I'm going to create a device here. I'm going to use the virt.io layers in KVM. So normally KVM simulates hardware, but it's kind of very inefficient for the other end to be, you know, pounding on bits and registers and stuff, and then have your computer trying to interpret and simulate an actual underlying machine. So there's all these fake devices, virt.io devices, which are devices that don't pretend to be hardware. So there's if your operating system has the drivers for these virt.io devices, it lets it just basically talk straight to the other end. So instead of flipping bits and stuff to set up a display, it just says, oh, here's what I want you to display, and kind of shortcuts that. So if you enable these virt.io devices, you can get considerably better performance. So the virt.io tablet is basically a mouse input. So I'm going to throw in another device. We're going to throw in the virt.io VGA display. So a fake VGA system. It doesn't have to bang any hardware bits. And then we're going to use the virtual I/O disk layer as well. And again, you know, the only reason I'm setting this up is because you know, normally I just burn this image to a USB drive and boot an actual computer, but in this case, I am booting up one that I can have in a virtual machine, so I can show it to you guys. So we got a virtual disk layer as well, and then we got to hook up a few devices to it. So a block device backed by a file. Give it a name. We'll just call it, that's our boot one. And then we're going to hook that up to the NixOS, the latest NixOS image, which I just finished downloading from the 1909 channel. There we go. And then we're going to hook that up into the SCSI CD device. Call that CD-ROM. And hook that back into this one here. This was the file boot, so we hooked the underlying driver back to the file boot. So now we've got the CD hooked up for booting. And then finally, we just need to hook into this QCOW2 system as the hard disk. So again, we'll create another file device and call this one just NixOS, say. And then the file name is the NixOS QCOW2. If you ever want to look up these options, I searched around on the internet for quite a bit of time while preparing this to actually figure out how to start up KVM. Probably you're better off to do the same thing and use a sort of front-end GUI program that lets you set these instead of doing them all manually. So that raw file, you have to run it through the QCOW2 system to understand the format. So we'll do that, block root. So that's actually got two layers, one layer to access the file, one layer to understand the QCOW2 format, and then finally the final layer to make it look like a SCSI hard disk. Hook that into the device. And then the remaining thing finally is to bring up the network. So we're just going to use what's called the user network stack. So basically this just masquerades it onto the Hydra system. So any network operations will appear to the rest of the world like as if they were coming from me on this computer. So that's that. And then we hook that into an actual virtual IO net device. Give it a name. And hopefully I got this all right. I'm not pulling this out of memory. I wrote this down. So let's give this a boot. So it's not happy with my block dev file, Nix latest NixOS image. So that's this one here. We roll back a little bit. It says parameter. That should be node name. And QCOS2, that should be QCOW2. And then CD-ROM, I got wrong as well here. Should be drive, not driver. All right, there we go. So it started up. So let's connect to this system now here. So we're going to start a VNC system. So I'm going to just start up my Tiger VNC viewer. Remember, I forwarded localhost 5900, which I said in the VNC lingo is :0. So we'll just connect to that. And so here's my remote start. So it says the guest has not set up the display yet. So let's boot the guest. We'll tell it so when you're in the QEM emulator, this is the monitor I was talking about. You have a whole bunch of options. You can snapshot and pause and inspect the state of the system. But all we really want to know is the C command, which tells it to start the simulation. So here I'm booting off I pretend I've burned my image to a USB key, and I'm booting up my machine now. So here it is. Linux is coming up off of this USB key. This is the minimal image, so it's going to take a little bit of time. It does some compression and stuff to sort of keep that size down there. You can see it's got a squash FS file system. So it's not particularly the fastest system because underneath everything's compressed and it's doing fancy tricks to map it all in to memory and stuff. But it works and it's not that big. Okay, so while that's booting up, let me show you some basic Nix stuff. So this computer here is my own personal system. It also happens to be running NixOS. I've actually switched all my systems to NixOS shortly. The last ones I switched were just this year, actually. It was still running some Debian, but they were badly out of date and needing updated. So most of the Nix commands, there was actually 2 versions of the Nix commands. Originally, all the commands were Nix hyphen something. So there was Nix hyphen REPL, Nix hyphen M, Nix hyphen this, Nix hyphen that. Then they reworked. So after having ran Nix for a while, they came up with a new command line system, and that's the Nix space. So very much like Git, it's Git space and some command. The new Nix commands are mostly always Nix space. So this is the REPL, read, evaluate, print loop, which is sort of your standard interactive environment for doing stuff. And this basically, if I press Control Help, this lets me run sort of stuff. And then, so these lines that start with a colon are commands I want to run myself. These are commands to the REPL, and everything else is interpreted as a Nix expression. So for example, let x equals 2 in x prints out 2. So this sets x equal to 2, and then it evaluates the expression x. So this is the Nix language, and it has a variety of features. X, this is the sort of setting variables, which you've seen. It's got hash maps as well. So I can say A equals 2, B equals 3, 4. Creates a hash map. All right. And now we've actually booted, so I'm going to just put that on hold here while we actually set up the NixOS system. So here we are. We've logged in on the. This is what you get. This is the NixOS installer. It's kind of a low-level installation sort of system. There's a graphical image you can boot, which will give you a graphical desktop, but you still basically do your installation from the command line. So the first thing, if we're going to do an installation, we have to become root. So let's just do a sudo on bash. I mean, you can sudo each of your individual commands, but I find it easier to just become root. Our system's booted up. Let's have a look at our devices here, specifically our hard drives. So dev SDA is the first of the hard drives, the SCSI disk, SD stands for. So if we had other ones, there'd be SDB and stuff. There is, let's just have a look at all the S drives. There is SR0 is the CD-ROM, so SCSI removable 0. Those are the two devices I set up when I booted the system. So if we're going to do an installation here, let me pop back to my notes. We're going to have to partition up this space. So that's our first step. And this is just a NixOS system. I can install packages, whatever packages I want to use it. It has the basic tools already installed. So you could use a graphical partition system, but why would you do that? So let's use the old GDisk, which is a rewrite of FDisk, which was the original horrible partitioning program for GUID or GPT tables, which was the replacement when Windows rolled out. They replaced the old DOS system. So this supports several different partition record formats. MBR, Master Boot Record, was the original one that came with DOS and persisted until I think about Windows, I don't know, Windows, it was still present in XP in 2000, so whatever came after that. Then they switched to this new GPT partition. MBR is pretty clunky. You can only have 4 partitions, except you can create an extended partition and stuff. So GPT is the way things have gone. And let me just make my screen here a little bit bigger. I can see it's clipping a little bit. There we go. Whoops, and I accidentally entered a command there, R, I did not intend to. So let me just see, I want to go back. Turn to the main menu. Yeah, so you press question mark and it tells you how to do stuff. I've used it enough times, I kind of remember how to do it. So we got a P here, we're printing. This is my QEM hard disk. It's 16 gigabytes, this many sectors. Helps to know that there's 512 bytes in a sector. So let's make our first partition. We press N, we look at the help here. N is the key to add a new partition, number 1. Partition number 1, these GPT partitions can have up to 128 partitions. The first sector, so the first 34 sectors are tied up with the GPT partition. It's suggesting I start at 2048 sectors. So if you multiply that by 512, that gives a megabyte in. And that's for alignment reasons. So originally disks were fast if you were aligned on sort of 512 bytes, and then it was 2K, and then it was 4K, and then SSDs came along. So they just recommend now that you line everything up on 1 megabyte boundary. So that's fine. We'll go with that as a good, for our first partition, the EFI system, starting at 1 gigabyte in. And then the last sector, we want it to be approximately 1 gigabyte, actually 1 gigabyte minus 1 megabyte. So let's just bring up a window here. Here we go. So we want, what we want is 1 times 1024 kilobytes, megabytes, gigabytes, and then we want that expressed in sectors. So our last sector is going to be 209715, and then we start. It's an inclusive, so we end at 51, just one short of that. There we go. What type of file system it is? Well, it's Linux is the default. That's not what we want. L to list the codes. We're going to search for EFI. We want the EFI system partition, so EF00. All right, so now we have our first partition here, just under 1 GB in size. We want our second partition. For the second partition, I'm going to wrap this. I had this little area at the start from 34 sectors into 2047 sectors, which is unused. We couldn't because we want to align on 1 MB, and because the partition entry took the first couple sectors of the hard drive, we left this approximately 1 MB chunk at the size unused. So we're going to come back now. We're going to fill that in with a partition table here. So it's recognized. We're going to go up to 2047. And we're going to put a BIOS boot area in there, which just means that's where the system can store bootloaders. So this entry is not required, but having it in there marks that area so someone doesn't accidentally come along and use it for something else. So that's where your copy of Grub and stuff is stored when you're booting on a legacy machine that doesn't have EFI. Okay, so now our third partition here. It's got the right starting address. This one is a correct actual starts and ends on even number of, it's exactly 14 GB. So let's just put that in, 14G. Linux file system is the right file system. Oh, that was the ending sector. I wanted to actually end at 15G to give me, so let's just delete that one, delete number 3. So new 3. Starting sector, and then the last sector here. Oh, and also too, it looks like this should be an odd number. So I'm going to actually calculate that correctly. So we want to end at, what did I say? End at 15G. So 3, 1, 4, 5, 7, 2, 7, 9, 1 short. Linux file system. Perfect. We got the 14 GB there. And then finally, the last one, partition 4. We'll just take up the rest of the disk. There's a duplicate copy of the GPT partition table at the end of the disk, so this won't be quite a gigabyte either. And then we want to swap partition. We want a Linux swap, so 8200. All right, so that is our partition system matching our sort of goals here, where we're expressing it in sectors, which are units of 512 bytes, where gigabytes are 1024 times 1024 times 1024. Now, just to make this compatible with DOS systems, if you want to boot it, you can go into this extra functionality menu here. And inside the expert functionality, there's an option to create a protective master boot record. So this actually creates an MBR record that surrounds your entire GPT. So in case this disk is ever thrown into a machine that doesn't understand GPT, it doesn't go and just say, oh, nothing's using this disk. So we'll create one of these protective MBRs. There we go. And then we can print it out. You can see this is a very boring one. It just says the whole disk is used. And code EEE means it's actually used by a GPT partition. So we have our two partitions, our actual partitionings of the GPT, and then we have a wrapping MBR just to ensure that doesn't get used. So our disk is good. Let's write this to the disk. We'll give the W command. Let's vote to write the disk. So we say yes. And now if we look at dev SD star, we can see we have SDA, which is the raw hard disk, and we have the 4 partitions as well. So with that in place, we can go ahead and build our file systems. So we're going to build a FAT file system for the EFI system. They recommend calling it EFI system partition, ESP. It's a FAT32 system, and that's on the first one here, dev SDA1. So format that. It looks like Windows or DOS might not be happy with a lowercase name, but I don't really care. And then the main Linux file system, SDA3, you could make this like an ext or a JFS or whatever you want. I've been using BTRFS. I'm not quite sure why, because it keeps abusing me, but I continue to use it. So we'll use that. It's supposed to be the better file system. I kind of called it the bitter file system because that's how I feel after it's done screwing me over. So make file system. And then finally, we want a swap as well in the end. So we'll make a swap onto dev SDA4. Okay, and then let's give that a proper label. We'll call that swap. And now if we look at our if we look at our disk by label links, we can see here's our disk. So we got the EFI system partition, dev SDA1, the NixOS system SDA3, and the swap. And then this was the original boot ISO on the SCSI removable. All right, so now to actually install Nix, it's super easy. We just have to mount our file system up. So let's do a dev disk by label. I mean, I could say dev SDA3 too, but so we're going to put the NixOS, we're going to stick it on the mount, which is just a spot where you can mount stuff up. Inside that, it needs a boot area. Typically in your root of your file system, if you look at, you'll see there's a /boot partition. Which contains a mounting of where it sticks files for booting. So that's the EFI system partition, goes there. ESP to mount boot. And then finally, let's turn our swap on too. Dev disk by label swap. Okay, so how do you install NixOS now? That was all just basically setting up our disk. Well, once you've got it set up, it's extremely easy to install NixOS. You run NixOS generate config, which looks at your system and generates a basic config file. Say, I want to you generate it for the root file system under mount. Okay, so that has created the etc directory and created my initial NixOS configuration. We can go have a quick look at this. NixOS hardware configuration. So it generates a hardware configuration which sort of abstracts the specifics of the machine, and then a more general configuration file which has the specifics of the sort of environment you're setting up. So basically this one here has recognized my client is a QEM, so it's actually set a profile to optimally use the correct drivers and stuff for that. It's got some kernel modules that says you're going to need these kernel modules present to boot based on looking at your system. And then it's identified the initial disks too here. And it's set it up to boot by their UUID. You could change these to the labels or the raw disk numbers as well. And then also it's realized, okay, this is a 2-core machine, so we're going to set the default Nix building system to be set to 2 cores. And this here is all just written in this Nix language, which I was demonstrating over there. So that's your hardware configuration, and that's pretty tied to, these are the drivers for your particular machine. A different machine might have different drivers. The more general configuration winds up under here, which sort of describes how I want the system to be set up. So the first thing it does is it sucks in the hardware configuration. Having those separate lets me just use this configuration across machines with different hardwares. So it's detected that I'm running, my QEM image is actually a legacy one. It doesn't have EFI support. So it's going to just do a standard grub install. I can uncomment these lines here to force it to also install an EFI system. So we could stick this image in an EFI system and it would boot. Grub needs to know where to install its stuff. So dev SDA, that's the actual root. It'll look at that hard disk image and it'll find that BIOS partition and stick it in there. Can give myself a host name if we want here. So traditionally, you would do these sort of settings in your, you'd pick a bunch of these options in your installation program, or you would go ahead and install it, and then you'd be editing files under etc. So NixOS being a declarative system, you just have it all in one system, that one file here that sort of specifies how your system's together. So internationalization, that works fine with me, English, US, UTF-8. Our time zone here, set that correct. So this would be America, Toronto. And all these options are the ones, precisely the ones here. If we go back over to this system here, we search for NixOS options. These are the ones that are documented on the NixOS options site. So say I look up time zone, here time zone, and it says America, New York as an example, description, default value, if it's set or not. I can set here, I can pick an initial set of packages to have in my system. I'm gonna have a very minimal system. It won't even have many of the common tools in it, but I could add like wget, vim, Emacs, whatever I want. Lots of people probably want to enable the GNU PG agent. For sure, we want OpenSSH brought up. Can set up the firewall settings, allowed TCP port. So I mean, you know, if you want to know how these options work, you just search here. List the TCP ports, so example 22 or 88, that would be open. You can do them by interface here as well. So I can say, so networking firewall interface ETH0, allowed TCP ports 22 or 80, whatever you want. Now, if you're going to enable X Windows here, you can turn that on here, set your keyboard layout and stuff. Pick your desktop manager. It's going to default to use the display manager. It's the simple display manager for my login screen. And this would be Plasma 5 would be KDE as the desktop. Of course, it fully supports, if I search for GNOME, I got GNOME 3. You have, helps if I can spell. I thought you had Enlightenment. Definitely have options like Sway, and I should be on the 1909 options because I'm booted up 1909 here. And then I can define my user account, so I can define the users. So I could say users, Tyson, what groups they're in, like if I want to enable sudo. And then finally, your system actually does have a bit of state to it when you boot it. Typical things would be like you might have a MySQL database and stuff. So all that stuff that generally lives under varlib and stuff. I declare this here, and when they upgrade, say, to a newer version of MySQL, it might not be compatible with the. So if I upgrade to NixOS 2009, its MySQL might not be compatible with the previous MySQL. So this here says my varlib, my local state on my machine, is for the 1909 install. So when I do an upgrade, actually what I do is I go read the release notes and scan through any of the sort of state breaking changes they make. And if there's none that affect me, or I might have to go manually, you know, update my MySQL databases that I'm using for my web front end to the new version of MySQL. And then I would bump this to the new state. Anyway, so that's our system. I'm pretty happy with that declaration there. So let's install it. NixOS install, root, mount. So that goes through, it looks at that configuration system, and then it goes into building a NixOS system. And that's basically it. Once it's done, I unmount, I reboot the system, and it comes up in my new NixOS system. And it looks like we're pretty much out of time, so why don't we open it up for questions, and then I can, this will take a while to install, so I can hopefully reboot it at the end of the question period.